So in one of my previous videos, I talked about how to set up a self-hosted infrastructure to run your self-hosted open source containers and environments. We talked about bare metal machines, a little bit about Docker, and a little bit about virtual machines, and a little bit about LXC and LXD containers. So most everybody has used virtual machines up to this point in time. And what I'm going to try to do is encourage people to consider running LXC and LXD containers. And that's what this presentation is a little about here. We're going to talk about how to do that. So what are the advantages of virtual machines compared with the advantages of LXC or LXD containers? Well, first of all, virtual machines virtualize all of the hardware. So that means they virtualize the motherboard, they virtualize the video card, the display, the keyboard, even they emulate the hard disk all the way down the line. So containers virtualize only the operating system, or a lot of people would consider them to virtualize only the application. The virtual machines have a software kernel, and sometimes that can be an advantage because if the kernel of your host machine that's running your self-hosting instances does not support a particular feature, then a virtual machine would support the latest features because its kernel is in software. So likewise, the containers use the host kernel. And that means that they can be limited to whatever that host kernel operating system has in it. And we'll talk a little bit more about that. So again, and this is somewhat redundant, each VM therefore has a separate kernel since everything is in software. And they can have different kernels for that matter. All containers share the same kernel in a container, as we talked about, because they're sharing the kernel of the host OS. And VMs are for running OS in general and virtualizing an entire system, whereas most people would consider that LXC and LXD are designed to run applications. Although there's somewhat of a caveat, and the lines are a little bit blurred because I've got LXC, LXD containers that are clearly running the operating system components and operating system services. Now, that being said, when we had all this talk about the kernel, well, you have to realize that a lot of operating system calls are made back to the kernel. So they're actually sharing the services coming from the host. And that's a key point about containers, that they share services. So in contrast to that, your virtual machines use dedicated resources. Because everything's emulated in software, every virtual machine has to have its own dedicated resources. And likewise, as I just mentioned, the containers have shared resources. They share the resources of the host that the container is running on. So VMs are not containers. I guess you gathered that from the description previously. And containers, one of the other advantages containers have is they're more portable. As a matter of fact, in some containerization environments, particularly in Docker, for example, you can have clusters of containers, and containers can fail over from one system to another system for reasons of failure, or sometimes for reasons of load balancing. So containers are very portable. And plus the fact that once you build a container, it's easy to back it up and provide it to someone else. So containers or virtual machines can run any OS at all. So if you have an ISO to install an operating system, you can install it on a virtual machine. In contrast to that, and one of the reasons they're called Linux containers is because they can typically only run Linux. Although in the most recent LXD 3.1 release, they added virtual machine support for QEMU, which is the Linux virtualization system. And some folks actually have procedures out there on how to run Windows inside of a Linux container. It's not really something that's recommended. I would say that in general, one of the reasons you want to run containers is to be a little bit lean and mean. And so running Windows is flies in the face of that. So most people have experience in using virtual machines, and some people have experience in using Docker containers. But fewer folks have experience in using LXC and LXD containers, and part of the reason for that is because those containers have a whole series of commands that you have to use from the command prompt in Linux to establish a container repository and do all the things you need to do. So in lieu of that, I thought I will describe those commands, but I thought at the front end I would show you that there's other ways. And in my infrastructure video, I talked about Proxmox, and Proxmox manages virtual machines, and it manages LXC and LXD containers. So I happen to be a QNAP NAS user, and both QNAP and Synology, which are big manufacturers of network attached storage, have a built-in application that allow them to do containerization, and that's what I'm in right here. So I'm going to go ahead and say I want to create a container. I'm going to say I want that container to be Ubuntu. I'm going to go over to the LXD image server, and I'm going to go ahead and say, well, I want to have a focal fossa container. So I'm going to go ahead and say install that. And I'm going to go ahead and call this thing test-ubuntu. And I'm going to try to spell it right. And then I'm going to say, well, I want this thing to be able to take up, say, 20% of the host resources. It doesn't mean it'll use 20%, but it'll say that you could take up to that. That's as opposed to a virtual machine where it kind of carves out part of the resources of the physical machine, whether it's doing anything or not. If this thing is idle, it might be using 0% of the CPU. And likewise, this particular host has 32 gigs of memory on it, but I'm going to go ahead and say, hey, you can use up to 2 gigs of memory, 48 megabytes. And then the only other thing I need to do is I need to go over here and define a network. So I'm going to go ahead and give it a MAC address I can find. My network will thank me for that, as opposed to having the MAC address change every time this system boots, this container boots. And I'm going to say I want you to be bridged to my main network. And then under devices, I'm going to say run containers in privilege mode. Why do I need that? Well, we talked about the fact that the containers use the system kernel. So in order to be able to make calls to the system kernel, that's a privileged event. And I do a create, and I do an OK. Go back here to my overview, and you can see already the device or the container is down here. If I look at the settings up here, it says it's already completed. So it downloads it, it creates it. If I go click on this thing here, it's already got a login prompt. So that's as in contrast to building a virtual machine. Because in the case of building a virtual machine, you would have to go out and install the ISO, go through the whole setup process of installing the operating system just as though you were installing it on a bare metal computer. But here, we can bring this thing up immediately. So moving along, I can click terminal here, and I can tell it, well, bring up a born-again shell on this thing. You're going to say, well, I sort of have a console down there. Yeah, but I don't know what the username and password is. So what I do is I come up here with this console prompt, and I can basically say add user Scott, and I can give it a password. And then I have a user account because this shell is running. Well, I guess it works better if you do the right command. So let's try user mod -a g sudo Scott. So I've added Scott to the sudo group. And then I'm going to go ahead and say apt install open ssh-server. And yes, go ahead and install that. And so it's going to go off and install SSH server on this thing. So now my container is installing my SSH server, and it's creating the appropriate keys for that. And now what I'm going to go ahead and do is an IPA, and it says that it is not yet telling me where it's running at. Oh yeah, there we go. 172.16.1.113. So I'll go ahead and open a terminal, and I'll go ahead and say SSH to Scott at 172.16.1.113. And yes, the fingerprint's fine. Type in the password, and there we are. We now have a terminal on the test Ubuntu machine, which you can't really tell from anything else. If I do a sudo apt install neofetch, and then I wait for that to install. And then I do a sudo apt install net-tools. Figured I'd give myself clear the terminal, do myself an if config command that comes out of nettools, and there you can see it's running at 172.16.1.113, and it's my IPv6 address also, and all that. So this thing looks like a regular terminal. If I do a neofetch, there we go. It says that I'm running Ubuntu 2004 because that's the container that I installed. It tells me what the kernel is. Again, this kernel, you see, comes from the QNAP NAS, unlike a virtual machine where the kernel would be part of the operating system and software. And the uptime here of 1 day, 13 hours is not how long this container's been up, but it's actually how long my network attached storage unit has been up. And it's also the number of packages installed is appropriate for this container. And my host machine really is an AMD Ryzen 7 Pro 1700. Okay, and it says what the total amount of memory is on it, but we told it that it could only use 2 gigs of memory. So this is the way you create a container and work with it in the simplest form. And this would work on a QNAP. It would work on a Synology. Proxmox is very similar to doing the same type of thing. And now we got to go off and learn how to do this from scratch on the command line if you don't have any of those tools. Okay, I'm going to shift gears a little bit here. And what I've just done is I have a virtual machine that I had created. And the only reason I created the virtual machine is I didn't want to mess with any of my bare metal machines. but I have a virtual machine that's created at 172.16.15.15. And this particular virtual machine is running Ubuntu 2004, and it's only running Ubuntu server. So there's no GUI on this thing. It's just simply a command line interface. So we want to see what is entailed in setting up LXD on a from scratch machine. So in this particular case, I've got Ubuntu server. I like working with Ubuntu server. I like working with Ubuntu containers because Debian containers are just kind of notoriously simple to work with to do this sort of thing. So I'm going to do a snap install LXD. So they have a very, oh, there we go. We better do a sudo. Sudo snap install LXD or LXD. And it says it's already installed. So apparently the server that I built had already installed that as a default. I guess it figures that you're likely to use LXD on a version of Ubuntu server, so therefore it's a pre-installed thing. But I'm going to go ahead and so I don't have to do sudo commands with all this stuff. I'm going to basically say sudo usermod -a g LXD Scott. So I have an account called Scott, and I just added Scott to the LXD group so that it can manage LXD. And then I could log back out and back in again to get that recognized, or I can do a new group LXD, and it'll go ahead and honor that. So then I can type ID, and lo and behold, it says that I am a member of LXD right here. So that's good. Okay, so we're going to go ahead and set up our device. We're going to go ahead and do a sudo LXD init. Would you like to use clustering? I default no. Would you like to configure a new storage pool? I say yes. And I'll just go ahead and say whatever it defaults to. I'll default to the ZFS file system because it's the newest. You want to create a new storage pool? Yes. Would you like to use an existing empty block device? No. And then size in gigabytes, it'll default to 30 gigabytes, so that's fine. And would you like to connect to a MOS server? No. Would you like to create a new local area network bridge? Yes, because I want to be able to talk to it. What should the new bridge be called? LXD BR0 is fine. What IP before notation should be used? Auto is fine. Okay, let's say auto. And would you like the LXD server to be available over the network? Yes, we would. And then the address to bind to, not including port, I want to bind to all addresses. And it says it's going to tie it into port 8443, that's fine. Password for new clients, I'm not going to create one. Okay, that's fine, I'll create one. All right. Would you like stale cache images to be updated automatically? Yes. Would you like a YAML LXD init press to be printed? No. And that is all we should need, I believe. Okay, now that we have our LXD daemon up and running, it's time to go out and actually use it for something to create some containers. So if we do a LXC list, you will notice that it says that there are no containers running right now. So the simplest way to create a new container is with the launch command. And the launch command looks like this. Oh, by the way, so you might wonder why all these commands are preferenced by LXC, and the reason is because LXC is a backend to LXD, and so really a lot of times people use the terms interchangeably even though they shouldn't. So LXC launch from the images repository, look for an image called Ubuntu, and look for a variant of Ubuntu called focal fossa, and then call my container Scott-LXD. I hit enter. It says creating the container, and it says remapping the container, and it's created it. If I do a list, there it is. So that quickly, I was able to create a container and start a container, and it's fully booted. So I'm going to go ahead at the same point in time, and I'm going to create a second container just so we can have more than one. And then we'll do a list on these containers, on this other container as well. Let's see. And it's created. So we do another LXC list. So now we have two containers running. If you recall, my address of my or of my Ubuntu-test machine that I'm running on here is 172.16.15.15, and so it's using the container network to put these containers on, which is 10.241.22. And in fact, if we do an if config, okay, well, if we install ifconfig, sudo apt install net-tools, you'll be able to see that the network interface, ifconfig, network interface for LXD BR0, we asked for that when we did the init command, created a network at 10.241.22.1. This is a little bit similar to how Docker does things as well, because we end up getting these internal networks, and we also have these external devices we can communicate to. So part of the security of containers is the fact that they have their own network. But aside from that, I want to go do some other things with it. So I'm going to go show you that you can connect to this thing. Now that we've listed a container out, let's go ahead and connect to the first container. And we can say, I want to execute LXC exec Scott-LXD, that's the name of the container, and Bosh, which is the Bosh command shell. If I hit enter, there we go. We've got a prompt on it. So we actually signed into the console of this particular LXD container. And I could sit there and say, it's running root, so I don't have to do sudo. So I could say like apt install neofetch. And it'll go off and install neofetch. And neofetch is kind of nice because it gives us information about the container that's running, and it gives us information about the actual kernel and all that. So we're waiting for this thing to run. So right now, all we have is we have a command shell way to get to the container. But we'd like to be able to get to that container through other means. And one of the things we'd like to do is just to be able to SSH to it like any other system, and then offer services on it, because we're going to install programs, maybe install a web server, do whatever we want on it. But the downside to trying to do that is right now this thing is off on this container network, this one that I just showed you. And unfortunately, because that is the case, it's not going to be reachable in all the ways that we need it to be reachable. Looks like neofetch has taken longer than I wanted it to. Okay, so now the installation is done. We'll go ahead and do a neofetch and see what we've got. So this is a little bit different because as opposed to the fact that the other one was showing up on the, as a virtual machine of the NAS, this is showing up as a container on the virtual machine, and the virtual machine is being emulated through QEMU. So it's saying, okay, my host is a KVM QEMU host, which is a Linux hypervisor, and it's giving me the latest kernel that Ubuntu would have. And the reason for that is because it's a software kernel, because it's a VM. And then it's telling me it's running this BOSH shell, and it's saying, well, this thing is an AMD Opteron 22XX, and the reason it looks like that is because that's how my virtual machine is emulating the machine type. Okay, so that just proves we can get to the machine. So let's go ahead and exit. We're back now to the virtual machine. If we do an ifconfig over here, we're going to be back at the 172.16.15.15. So in this virtual machine, what we need to do in order to let our containers talk to the main network is we have to modify the network configuration of the host that's running the LXD. And in order to do that, we're going to have to go over to /etc/netplan. And then I'm just going to do a sudo su because I have to do a mess of privilege commands. I'll do an ls. There is a file. You'll probably have a YAML file over here. So if you have a YAML file over here, just go ahead and edit that nano file. So I'm going to edit that nano file. And it's got some stuff in it, which makes sense. There's the static address of the server, 172.16.15.15 with a subnet mask of 16. And then the gateway is 172.16.0.1. That's the address of my router to get off the network. And then I've got two addresses for name servers down here. So what I'm going to do is I'm just going to go ahead and delete this whole mess. And I am going to replace it. I'm going to instead say this is a network configuration for a bridged network. Okay, so you would have thought that I would have noticed at the end of this file that I had LXC list on the end of that no, but of course I wasn't. I was focused on other things. So yeah, it's supposed to be DHCP4 is no and DHCP6 is no. So we're going to come out of here and now we're going to do the sudo netplan generate, and it works perfectly, which is exactly what we wanted to see. And then after we do that, the next command is going to be a sudo netplan apply. And we do it, and it works perfectly. Now, at this point in time, you kind of disconnect yourself from the network. If I hit enter a bunch of times, nothing happens. And the reason that nothing happens is because we basically rip the network out from underneath this connection, and we have to wait for the container to reset itself and come back. And when it blew those carriage returns in there, it actually came back. So that's good. The virtual machine is back and it's alive. And to prove it, I can do an LXC list, and there's my two LXC containers. So now that we have our bridged network, if you do an ifconfig, you will see that I have a ENS3 like I did before, but this ENS3 isn't assigned an IP address. Instead, this thing called BR0, which is the name of my bridge, it has the IP address, and you can see that it got an IPv4 address that I statically defined, and it's got an IPv6 address also. So I've got an IPv6 global. My network does both, so I use IPv4 and IPv6 for different things. Okay, so now that we've got that squared away, now what we can do is if we do an LXC list, clear this off, if we do an LXC list, there's both of our containers running a Net10 network. Now, suppose I wanted to configure that second container on the main network. I go ahead and do an LXC config device add to the container Scott-LXD2. Its device is ETH0. If we looked on that container, we'd find out, if we did an if config, we'd find out the name of its Ethernet device is ETH0. That's always the case for LXD containers. And I said, add a NIC. NIC type is bridged, and the parent device is BR0. So it'll use BR0 from the host, and it'll go ahead and do its thing. So it says device added. So now if we do an LXC list, you're going to notice that LXD2 has no IPv4 address. And the reason is just like when we did the netplan command, the system is in the process of reconfiguring itself. And we've got to wait a little while for it to reconfigure before it actually has an address. So we're waiting, and do another list. We're still waiting. And notice here, in the meantime, it's gotten an IPv6 address because that's no longer blank. And we do it again. And voila, there's an IPv4 address at 172.16.1.209. So it actually got an address. So what we want to do next is I'm going to go ahead and connect to this second container, the LXD2 container, via Bash. So there's my command shell into the second container, and I'm going to do an apt install net-tools on this container, just so I have that. It's going to go off and think about it. Hopefully it won't take as long as it took on the other. Nope, this one went fast. And then we're going to say an apt install, let's see, open SSH-server, because we want to be able to SSH into this thing. And then right now, you'll notice whenever you connect to a LXD container, you don't actually have any user account, but the root user account. And for security reasons, you should always have another account. But also, I don't even believe SSH will work to a root account anyway, because it's set up with protection to avoid that type of thing. And you wouldn't want to leave that open on your network in any event. So we're waiting. It's about to come back. And I'm going to create myself a user account is what I'm going to do. It has to create keys for SSH because we're going to connect to it. My last video went over SSH keys. All right, so we're going to do a user mod, or no, wait, not an add user Scott. So let's do an add user Scott. Create myself a Scott user account. Give it a password. Okay, and then I'm going to do a sudo. I guess I don't need to do a sudo. I can just do a user mod -a g sudo Scott. Give the Scott account sudo because we need it. And then do an if config. And you see this thing's running at 209, 172.16.1.209. So I'll go ahead and open another screen. And on this screen, I'm just going to go ahead and do a SSH to the Scott account I just created at 172.16.1.209, which is the address of this container. And it says, yes, I want to fingerprint it. And I type in my password, and I'm logged in. So I can do an if config here. And there we are at 209. Stretch this out a little bit so we can see it. And I can do a neofetch, same as I did locally before. Oh, we don't have neofetch on this one. We installed it on the other container. So let's do a sudo apt install neofetch. So the point in all these installs is you can see that you can install any programs you want in a container, and a container can run exactly like any host system or any VM. But the other thing you should notice is how much faster a container is. It really doesn't have a long boot up process. It doesn't have any installation process other than bringing a copy of the container down from the container repository. And you can do anything you can in a container pretty much. The only caveat is if the machine you're running on the container on does not have a particular kernel resource, then you might not be able to use a LXC, LXD container on that particular device. A good example of that was I tried to run a WireGuard container on my QNAP container station, and I couldn't do it because the QNAP did not have the latest kernel that came out in March of this last year that had WireGuard support in the firmware. And so consequently, I had to create a VM and run my WireGuard on it because I didn't have that capability otherwise. So there's an example. I've seen other examples too. You could have a really old kernel that maybe didn't support something like C groups, you know. Anyway, neofetch. If I could spell, I'd be much better off, or rather type neofetch. So there you go. Again, QVM, QEMU, but this time we're on a terminal SSH directly into that device. All right, so we're going to exit. We're going to exit this terminal from my main host. We're going to exit this console, and we're going to exit the string there. Now we're back to Ubuntu test. We're going to cd tilde, which brings us home, and we're going to do a clear, and we're going to do an LXC list. Okay, so one of the things we can do is we can say LXC stop Scott-LXD, which just stops a container. And you can do an LXC list and see it says the status of that container is currently stopped, so it doesn't have an Ethernet address or anything like that. You can also say LXC delete Scott-LXD. We could have done a start to start it back up, by the way. We can do a delete, and now when we do an LXC list, the container's gone. And it's just that easy to work with containers. Okay, so that's kind of it for the basics of LXC, LXD containers. What did we learn about this today? Well, first of all, we learned that containers are very efficient. As a matter of fact, they can even run on a Raspberry Pi. You probably couldn't run very many virtual machines, if any at all, on a Raspberry Pi. I know there's some very efficient small ones you can, but you can probably run 4 or 5 containers on a Raspberry Pi 4 without a problem, and they would actually perform fairly well. So you saw how quickly we could deploy a container, get it up and running, and connect to it. LXC, LXD containers have a really nice front-end interface on QNAP and Synology Container Station NASs, and also Proxmox has a really nice interface. So that's what makes these things a little bit easier. But if you don't have any of those things, then you can just use a machine and create your containers on it the way I showed in this video. Containers can run on a container NAT network. That's where they run by default. And a bridge network adapter can allow for containers to be offered on your LAN directly via that YAML file that we went over and the netplan command, which reconfigures your network to use a bridged adapter on your host machine. A container network connection can be changed with the LXC config device to add a container connection to bridge to a LAN. And you can generally install any program in LXC, LXD container that you would install on a bare metal server. I mean, I kind of showed off that you can install NeoFetch and you can install the OpenSSH server, but certainly you can install Apache or any other program for that matter. I have a lot of things on my network implemented in LXC, LXD. As a matter of fact, I probably serve out about 40 containers, and out of those, I would say that only about 2 of them are virtual machines. So containers boot almost instantly, and they use only the resources they need. They don't carve out resources like memory and CPU cores the way a VM does. So you can actually run quite a few LXC, LXD containers apparently in parallel. Anyway, that's about it for today. I hope you all learned something, and thank you. I'd like if you would subscribe and like, and we will talk to you next time around. Thank you so much.